I didn't set out to build a website. I was trying to solve a different problem. Over time, my thinking around our transformation, artificial intelligence, enterprise architecture, governance, product engineering, and delivery had started spreading across different places. Some ideas existed as a LinkedIn post, some were captured in architecture diagrams, some became technical experiments, others became working prototypes, tools, applications, and deployment pipelines. Each individual items made sense on its own, but the complete journey was becoming difficult to follow. The post could explain one idea, a diagram could explain one architecture, a prototype could demonstrate one capability, but there was no permanent place where the complete thinking, implementation, evidence, and evaluation could remain connected. So I needed a structured home for the journey, a place where ideas could stay linked to the architecture behind them, a place where architecture decisions could remain connected to implementation, a place where prototypes could show not only what worked but also how they were governed, validated, and improved. At first, the answer looked simple: create a website, publish articles, show the prototypes, organize the content. But the moment I started building it, the real challenge became visible. A website can publish information. What I needed was a system that could connect ideas to architecture, architecture to engineering, engineering to deployment, and deployment to evidence. That is when the platform started changing. It could no longer remain only a personal website. It could not be only a digital profile, an online resume, or a collection of technical articles. It had to become a working architectural lab, a place where question could become a requirement, where a requirement could become an architecture decision, where an architecture decision could become a prototype, where a prototype could become a governed product, and where every implementation could leave behind evidence that could be reviewed, tested, challenged, and improved. That changed how I looked at the website itself. The website became the visible interface, but the real work was happening underneath it. The first operating model was still fragmented. Artificial intelligence helped with architecture evaluation, design, troubleshooting, technical writing, implementation planning, and engineering support. Files moved through control exchanges. GitHub maintained source control, change history, and release governance. Cloudflare provided the runtime, deployment platform, storage, and production environment. Every tool had a purpose. Every tool worked, but the complete operating model was still dependent on manual coordination. I was moving the files. I was transforming outputs between systems. I was checking versions. I was comparing result. I was validating whether one tool had completed that another tool expected. The tools were automated. The operating model was not. I had become the integration layer. That was the important realization. Using multiple automated tools does not automatically create an automated delivery model. True automation appears only when the handovers, validations, evidence, and decision boundaries between these tools are also designed. That became the next architecture problem to solve. The model had to evolve from collection of useful tools into a control engineering system. GPT became the architecture evaluation, review and decision support layer. It helped define the product direction, architecture, boundaries, implementation, topology, governance requirements, test expectation, and release criteria. Codex became a repository level implementation engine. Later it became CLAN. It worked directly with the approved code base, implemented boundaries, executed tests, corrected defects, and product technical evidences. GitHub remained the source control and governance boundary. It prevented change history, release scope, reavailability, and rollback capability. Cloudflare maintained the runtime and deployment layer. It hosted the platform, supported the application architecture, and provided the operational environment where the result could be validated. The human role also changed. Instead of spending most of the time moving files and coordinating tools, the focus shifted toward higher value responsibilities: intent, architecture, security, validation evidence, production impact, reversibility, accountability, and the final decision. This is where artificial intelligence started becoming genuinely useful, not as an independent production authority, but as a part of governed delivery model. Artificial intelligence could assist with generation. It could support diagnostics. It could propose architectural options. It could execute implementation tasks. It could generate tests. It could document decisions. It could identify defects and suggest corrections. But it did not own production. Human intent remained explicit. The architecture boundaries remained controlled. Validation remained automated wherever possible. Evidence remained visible and accountability remained human. That distinction matters. Without governance, artificial intelligence can increase speed but also increase uncertainty. With governance, the same capability can support controlled acceleration. That became one of the most important principles behind the architectural lab. The goal was not simply to build faster, the goal was to move faster without losing control. Behind the visible website, the platform continued to grow. Articles became structured knowledge. Architecture's decision became reusable pattern. Prototypes became working demonstrations. Experiments became repeating engineering flows. Applications became governed product. Products started carrying their own evidences, validation results, maturity boundaries, and operational context. The website therefore became more than a publishing platform. It became a place where thinking, implementation, and evidence could remain connected. The article explain why a problem matters. The architecture explains how the problem could be approached. The prototypes demonstrate whether the idea can be worked. The product show how the capability can be delivered. The evidence explains what was validated, what remains limited, and where human judgment is still required. Every build created new questions. A successful prototype created questions about scale. A deployment created questions about governance. Automation created questions about control. Artificial intelligence created questions about trust, evidence, and accountability. Those questions shaped the next iteration. The platform became a living cycle. Ideas became architecture. Architecture became implementation. Implementation produced evidences. Evidence created learning. And learning shaped the new idea. The cycle is the real architectural lab. It is not a static collection of completed work. It is an evolving system where every article, prototype, product, architectural decision, and failed experiment contribute to next stage. The website is therefore only the visible layer. The real product is the operating system behind it. The architecture, knowledge, source control, implementation, testing, deployment, security, validation, recovery, governance, and continuous learning, all connected through one delivery model. This also changed meaning of personal knowledge sharing. The objective is no longer only to publish an opinion or demonstrate a tool. The objective is to show the complete journey. What problem was identified? What architecture was chosen? What alternatives were rejected? What was implemented? What evidences was produced? What failed? What was corrected? What remains constrained? And what should happen next? The level of transparency is important, particularly when the topic is SAP and artificial intelligence. Enterprise systems cannot be designed around attractive demonstrations alone. They require architectural discipline, they require security, they require traceability, they require controlled deployment, they require recovery, and they require clear human accountability. This is the deeper purpose of the architecture by Prasad. It is a place to explore how enterprise architecture, SAP engineering, artificial intelligence, governance, and the product delivery can work together as a one system. And now the journey is adding a new layer, visual learning. Long articles and technical architecture documents remain important. They provide depth, context, evidence, and detailed reasoning. But not every learner starts with long articles. Sometimes a visual story can establish a context more effectively. A short architectural video can explain the problem. A diagram can show how the components connected. A narrated journey can make the decisions easy to understand. That is where YouTube becomes a part of architectural lab. The website remains a detailed knowledge layer. LinkedIn remains a discussion and discovery layer. YouTube becomes the visual learning and context setting layer. And the working products, prototypes, and architecture evidence connect all of them. Architecture by Prasad is not only a website, it is a living architectural lab where ideas become architectures, architectures becomes prototypes, and prototype becomes products, and products produce evidences. The website remains the permanent knowledge layer. YouTube becomes a visual learning layer,